Alright, so I'm going to give you all a little tutorial over solving trigonometric equations. Okay, hopefully my terrible technology will not get in the way. But as you see, I start off with the unit circle. Alright, we've got our pi over 6, our pi over 4, our pi over 3, and our pi over 2 radians, and the things that match them. These are the only things we need to remember. Square root of 3 over 2, 1 half. Square root of 2 over 2, square root of 2 over 2, all those things, and then there's positive here, negative positive here, negative negative. Let me go ahead and write some. This is 0 pi, okay, radians. This is pi over 2 radians. This is pi radians. All right, 3 pi over 2. And of course, 0 pi is the same as 2 pi, and that's very important. 0 pi plus 2 pi plus 2 pi again plus 2 pi again plus 2 pi again, it's the same thing. So anything plus 2 pi again is the same thing. You really need to remember that before we get started. All right, so first example I have is sine x equals 1 half on the interval negative 2 pi to 2 pi. This just means as we find our answers, we need to try to find as many as possible, all the way up to negative 2 pi included, all the way up to 2 pi included. So let's look at the unit circle. Where's sine x 1 half? Sine is equal to the y value. The y value is 1 half right here. That's pi over 6. Okay, well, looking for a positive 1 half. It's going to occur here. See where the positive sign on the 1 half? And it's going to occur here, right? The same position. Well, this is pi minus, well, that's pi over 6. Pi minus pi over 6 is going to give us that. All right, so basically, the process I go by, I keep this step right here. Let me show you, just because I like it, and just because you would do this in your calculator, right? All right, sine inverse of 1 half equals 0, but also not 0, x. All right, x, and then I write my solutions for x. Well, I know one of my solutions is pi over 6. One of my solutions is, pi minus pi over 6, which is 5 pi over 6. Okay? Now, what I want you to understand is what we just said earlier. Okay? 0 pi and 2 pi are the same. So you can add 2 pi to any one, or minus 2 pi from any one of your solutions. And as long as it's on the given interval, I mean, if you don't have an interval, you can go as far as you want. In fact, you have to write it as a sequence, right? All right, so let's do that real quick. Let's write it as a sequence just to show you. You don't have to do this on this assignment. I'm going to show you real quick. All right, so x equals pi over 6 plus 2 pi n, where n is an integer. So this could be plus or minus 2 pi. You can plus or minus 2 pi to any one of your solutions, and it's the same thing because you're doing a revolution. And 5 pi over 6 plus 2 pi n. Once again, you can plus or minus 2 pi to any one of your answers because it's just a revolution and ends up in the same radian position. But that's not what we're doing here. Basically, we can kind of do this. It's kind of you kind of just throw in, you're kind of just adding your 2 pi as much as you can. All right, so let's start with pi over 6, okay? And let's write down 5 pi over 6 as well. All right, what I need to do is I need to say, okay, I can go 2 pi more than pi over 6. So what's 2 pi? 2 pi is 12 pi over 6. Right? So add 12 pi over 6 to pi over 6, you get 13 pi over 6. Okay? Add 12 pi over 6 to 5 pi over 6 is 17 pi over 6. Okay? Now what's the problem with this? We're trying to stop at 2 pi. 13 pi over 6 you divide that, that's too much. That's like 2.1 pi. So that's too much, and that's too much. Okay? But we can take the same principle and reverse it. All right? 5 pi over 6 minus 12 pi over 6 is, was that negative 7 pi? No. Yeah. Negative 7 pi over 6. And pi over 6 minus 12 pi over 6 is negative 11 pi over 6. And if I go any further, I'm going to be less than negative 2 pi. So I can stop. And basically, once you find all the solutions on a given interval, you just kind of stop. And there you have it. Oops, sorry. Writing and filming at the same time doesn't really work. All right, so don't worry about the interval the sequence notations, the series notation. Don't do this. Don't do this. Just know your unit circle. Oh, I'm sorry, I missed the last one. I missed 5 pi over 6. Okay. You know your unit circle right here. All right. Sorry about that. That's aggravating me. You know your unit circle right here. You know the solutions are pi over 6 and 5 pi over 6. Apply the principle of adding 2 pi, and if it's too much, just leave them out. And then apply the principle of minusing 2 pi here and here. But don't go too far. I didn't go too far. Any more, what would the next one be? Negative 7 pi minus 12 pi over 6 would be negative 19 pi over 6. That's way less than what I want, okay? Negative 2 pi. So let's move on to the next one. All right, cosine x equals 1/2. Once again, I'm going to do the same thing that I did before. Cosine inverse 1/2 equals x. So x equals the radian in which cosine is 1/2. Cosine is the x, so as cosine is 1/2 at pi over 3. And it's also, well, that's here the cosine is negative 1/2 at this point. But it's positive 1/2 at this point. Okay, so see how they reciprocate? They're equal x values right there. All right, so that would be that's pi over 3. So this is 2 pi minus pi over 3, which would be 5 pi over 3. Okay, so I know right off the rip, I know my solutions are pi over 3 based on the unit circle, and 5 pi over 3. And if you don't know that this is the same, you're either going to have to restudy your unit circle, or you're going to have it drawn out every time. The whole thing drawn out. All right. Now, once I have these solutions, I apply the principle from 0 to 3 pi. I can add 2 pi, which 2 pi is 6 pi over 3. I can add 6 pi over 3 to each of these as many times as I want, and I can minus 6 pi over 3, but 0 is right here. I can't minus 6 pi over 3, I'll be negative. I don't want to be less than 0, so I'll do this one, and that's going to give me 7 pi over 3. I'll do this one, and that's going to give me 11 pi over 3. All right, now, have I gone too far? Well, I believe so, because 11 pi divided by 3, that's more than 3 pi. This is less than 3 pi, so I know I can just basically stop here. Okay? And those 3 are my solutions. Okay? Now, domain restrictions. Let me talk about domain. There are none for a sine x or a cosine x, or a sine x, or even a 2 cosine 2x. But when you get in a tangent, there's domain restrictions. We'll talk about that later. All right, next example. Sine x equals negative square root of 3 over 2. So let's look where y is square root of 3 over 2. Y is square root of 3 over 2 right there. That's pi over 3. But it's negative square root of 3 over 2 right here and here. So that would be 5 pi over 3. Okay, let me double check. I'm working a little too fast here. Yeah. So 5 pi over 3 and 4 pi over 3. Okay, 5 pi over 3 and 4 pi over 3 are where the y value is negative square root of 3 over 2. So let's write our answers down. And like I said, I always do this. Sine inverse negative square root of 3 over 2 over 2. All right, there we go. Equals x. Therefore, x equals, well, what did we say? We said 4 pi, and notice I'm giving myself room. 4 pi over 3 and 5 pi over 3. Because I know I'm going to add or subtract 2 pi. And look, I can go as big as 2 pi and as small as negative 2 pi. So if I add 2 pi here, that's 6 pi over 3. I'm going to be way over the 2 pi mark. Okay? So I'm not going anywhere more. I can't add 6 pi over 3 to either of these. I'll be too much. So I basically can stop. Now I'm going to minus 2 pi over 3, which is 6 pi over 3. So 5 pi minus 6 pi over 3. 5 pi over 3 minus 6 pi over 3 is negative pi over 3. And 4 pi over 3 minus 6 pi over 3 is negative 2 pi over 3. And I'm almost, negative 2 pi. And I'm almost out of room, but if you notice, if I minus another 6 pi over 3 here from this guy, I will be at negative 7 pi over 3, which is less than negative 2 pi. So I almost didn't give myself enough room, but it's all good. Those are my solutions. Those are my x-intercepts, okay? Well, not x-intercepts, solutions to these equations. If it was function equal to 0, it would have been an x-intercept. Now let's take a look at this funky guy. Here, I can't even begin to solve this problem. I simply cannot. And, well, you know, this problem is actually not even what I wanted to look at here. I wanted to look at this as 1. So I'm not even ready to solve this because this has to be by itself. Okay? I got to get rid of the coefficient. Got to get rid of the coefficient. So I divide. I get cosine 2x equals 1/2. Now I want to find out where the cosine is 1/2. So cosine inverse 1/2 equals 2x. Only difference is there's a 2 by the x, but that's fine. Still do the same thing. So where's the cosine 1/2? Cosine is 1/2 at pi over, no, not pi over 6, pi over 3, and it's positive 1/2 down here. And that's 5 pi over 3. So pi over 3 and 5 pi over 3. Okay? So 2x is equal to, I'm going to give myself some room again. I'm going from 0 to 4 pi, so I don't need much room over here. So pi over 3 and 5 pi over 3. All right? And I'm going to do the same thing. I'm not worried about that too, really. I'm going to do the same thing. But what's going to happen is I got to solve for x, so I'm going to divide that by 2. So it's going to make all my answers half as small, or half as big. Okay? So even though I'm going to add 2 pi, which is 6 pi over 3, I got to keep in mind that all the answers are going to get halved. Okay? So let's add 2 pi, which would be 6 pi over 3, so 7 pi over 3. And then 11 pi over 3. And then, what's the next one? 13 pi over 3. And then, what's the next one? 17 pi over 3. And then 19 pi over 3. And 23 pi over 3. And I think I'll stop there. When you notice, well, 23 divided by 3 is like 7 point something. So I went way over the 4 pi mark. But remember, all these answers are going to get cut in what? Half. So I've got to take that into consideration. So if I solve for x now, I've got to multiply everything by a half. So all these answers here will be multiplied by a half. So cancel. And I'm just going to put everything in parentheses and put a 1/2 on the side right there. See that? And so now my answers are pi over 6. And you see how that just half? Pi over 3 becomes pi over 6. 5 pi over 3 becomes 5 pi over 6. The only thing that changes is the bottom and the fact that their half is small. So let me go ahead and write all these solutions. And what is 6 times 4? 6 times 4 is 24. So you know you got to go up to at least 24, all right, or no more than 24. 11 pi over 6, 13 pi over 6, 7 17 pi over 6, 19 pi over 6, 23 pi over 6. Alright, so now those are all our solutions. Now, did I get all the way up to 4 pi? Well, 23 pi over 6 divided 23 divided by 6 is almost 4. So let's add another 6 pi over 6. Well, see, now we were adding 6 pi over 3, but notice what's happened now. Now even the pattern has changed. We're not adding 6 pi over 3 anymore. We're adding 6 pi over 6. So the pattern has decreased in half as well. So let's look at this 19 pi over 6, and you add 6 to that, that'll give you 25 pi over 6. Well, if you divide that, 25 divided by 6 is too much. It's going to be over this 4 pi. So we're done. Okay, those are our solutions, our solutions for this equation. I know it's hard to see. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, 13 pi over 6, 17, 19, and 23 pi over 6. All right, so hopefully this helps you. Remember, you've got to get rid of your coefficient, got to get the sinusoidal by itself, and then you can do your cosine inverse. And who cares about the 2x? Just put it off on the side. Figure your solutions. Know they're going to be half as small, and then write them out when you're done. All right, so let's do the last one. Tangent squared x equals 1/2 from negative 2 pi to 2 pi. Sorry, my negative sign's off. So, so let's get started. I'm just kind of running along. I'm rushing. So, all right, get some more room. So tangent squared x equals 1/2. The problem is, not only do I have to get rid of the coefficient, I have to get rid of the squared too, okay? Because that's almost like, you could rewrite this as tangent x squared equals 1/2. Now look at that, that sinusoidal is not by itself. It's got a squared on it, so we get rid of it by square rooting. Okay, so square rooting, cancel, cancel. Tangent x equals, square root of 1 is 1, square root of 2 is square root of 2. Now that doesn't occur anywhere in the unit circle, but I would never give you a problem that you couldn't solve unless you exhausted all proper things, proper avenues. All right, so if we actually rationalize this denominator, okay, multiply top and the bottom by square root of 2 over 2, square root of 2 over square root of 2, all right, this becomes square root of 4, which is 2, so we have tangent x equals, on the bottom we have 2, on the top we have square root of 2. And another thing that I failed to mention here is that when I take the square root of both sides, I always have a positive and a negative, okay? Always a positive and negative. So we're going to solve one of these for positive square root of 2 over 2, and then we're going to solve one of these for negative square root of 2 over 2, and then all that's going to be our solutions there. All right, so let's solve this one first. We'll square root of 2 over 2 for tangent. Well, I'll tell you what, I don't think the tangent isn't equal to square root of 2 over 2 anywhere. Oh, never mind, bad question. Well, I guess I did give you an unsolvable question. Let me do, oh man. So this is, all right, so let me do this. X that out, sorry. Wasted 3 minutes. Okay, so, all right, 2 tangent x, 2 tangent squared x equals equals, let's see, equals square root of 3 over 2 square roots of 3, or 6. Let's just do 6. Okay. All right. Let's see if this is going to work out. Need to get a good problem before I start. Sorry, pause. Okay. Okay, yes, all right, so now we have 2 tangent squared x equals 1/6, all right? So what we do is, of course, we divide both sides, well, doggone it, 1/2, that needs to be 1/2. 1/2 tangent squared x equals 1/6, okay? So what we're going to do is we're going to multiply both sides by 2. You're going to get tangent squared x equals 1/3 now. You're going to take the square root of both sides here, and then you'll have tangent x equals, square root of 1 is 1, so it's just 1 over the square root of 3, and then tangent x equals negative 1 over the square root of 3. Okay? So either of these could occur, right? So where is the tangent x equal because you took the square root of both sides? Okay? So because you took the square root of both sides, either of these could occur. Tangent x is equal to 1 over the square root of 3 because the square root of 1 is 1, and the square root of 3 is the square root of 3. Okay? And then the square root always has a positive and a negative answer. Okay? So we know the tangent x is equal to x to y over x. So for which one of these, if you put the y over x, would you get 1 over the square root of 3? Well, it's this one right here. Because if you put 1/2 over the square root of 3 over 2, okay, 1/2, let's write that out. 1/2 divided by square root of 3 over 2. And the one on your thing, on your assignment is not this hard, but that's fine. You keep flip change the bottom. Take the reciprocal of the bottom and multiply 1/2 times 2 over the square root of 3. 2's cancel, you get 1 over the square root of 3. So my solution is pi over 6. But where else would I get a positive solution for this? Positive 1/2 divided by positive square root of 3 over 2, and negative 1/2 divided by negative square root of 3 over 2. Okay? Which is right here. Wait, no. Yes, and negative 1/2, this over square root of 3 over 2 negative, down 1/2 negative. Okay, that would give you the same result. Okay, so let's list the solutions, and our interval was negative 2 pi to 2 pi. Okay, so x would equal pi over 6 and 7 pi over 6. Okay, now remember you can add 2 pi as much as you want or subtract as much as you want. Well, if I add 12 pi over 6 to either of these, I go over, but I could minus. So I'm going to make myself some room. Pi over 6, 7 pi over 6. Okay, and then I can subtract 12 pi over 6 from both of these. 7 pi over 6 minus 12 pi over 6 is negative 5 pi over 6. And I'm about to run out of room again. Pi over 6 minus 12 pi over 6 is negative 11 pi over 6. And there you go. Any more will take you less than the negative 2 pi that you want. Okay? All right, so what about the next one? Tangent x equals negative 1 over square root of 3. Well, all right. So what would divide and give us a negative solution? Well, if you do something positive divided by something negative, or vice versa. All right, something negative divided by something positive. So the solutions are going to be the same, except for they're going to occur right here and right here. And that's 11 pi over 6 and 5 pi over 6. So here we go. 5 pi over 6, 11 pi over 6. And once again, I'm just going to backtrack. That's negative 1 pi over 6. And that would be minus 12 pi, negative 7 pi over 6. And any more would get you into trouble, right? Okay, so I'm sorry for all this junk on the bottom. That was a bad example. All right, so those are the solutions to this equation right here, right? This equation that we started off with, 1/2 tangent squared x equals 1 over 6. What about the domain restrictions? The domain restrictions occur where the bottom of the function is equal to 0. or sorry, the bottom of a fraction is equal to 0. Well, tangent squared x is a fraction, okay? Now, it doesn't matter, the squared doesn't matter. We know that tangent x equals sine x over cosine x. So if we isolate, or in this case, tangent squared x equals sine squared x over cosine squared x, right? So if we just take the cosine squared x right there, I don't really even care about the 1/2. I want to know where is the bottom of this fraction equal to 0. So cosine squared x equals 0. Square root both sides, but it's insignificant. Cosine x equals 0. Now where's the cosine x equal to 0 on this interval negative 2 pi to 2 pi? Well, cosine is equal to 0 at 0. Is equal to 0 at pi. Wait, sorry. Cosine's your x, sorry. Pi over 2 and 3 pi over 2. And then you can subtract as well. So pi over 2, right? I'm running out of room. I'm totally out of room. So let's go down here. X is equal to pi over 2. 3 pi over 2. And you can subtract. You get negative pi. No. Yes, negative pi over 2. Okay. And then negative 3 pi over 2 as well. Let me rewrite the whole thing. And these are your domain restrictions, because those are where the bottom of the fraction is equal to 0. Okay. Now, I'm sorry this was so long, but hopefully it helps with some of y'all. And sorry it got kind of squished together at some points. I appreciate y'all's patience and work hard. Thanks. Bye.